We're going to get into adding and subtracting rational expressions now, moving on from the multiplying and dividing, which we previously have done. We're going to start with the easier ones, which are those that have common denominators. You're probably not going to see these too often. We're going to be mostly given uncommon denominators, but I just wanted to show you how, let's say you had a basic example, 1/4, and then you added 2/4. Okay, well, that would be 3/4. You know this, right? You know keep the denominator. We're just recalling keep the denominator the same and just add the numerators. That's the process we're going to be using here when we have common denominators already. So as you can see, example 1, we already have common denominators. So what we're going to do is keep it. K squared plus 3k. And we're going to subtract our numerator. So we have 2k squared. Now this subtraction goes to both terms. Now that's where mistakes are made. 2k squared minus k squared is k squared. And then we have a minus 9. Alright, so we've combined our two fractions into one, which is what this lesson is all about. But we can't leave that as our final answer because it can be reduced, just like we did when we did simplifying rational expressions. You have to always make sure it cannot be reduced anymore. Well, this can be reduced because k squared minus 9 is k plus 3, k minus 3. And we have a common factor of k times k plus 3. Now we can reduce to 1. K plus 3 over k plus 3 is 1. So we're left with k minus 3 over k. I'm just going to move this stuff over real quick here. Oop. Well, I could do that. There we go. Alright, so for example 2, again we have a common denominator, 4x squared minus 1, that's our common denominator. On top we have x squared plus x squared, which is 2x squared plus x. And that's going to be x times 2x plus 1. And this is going to be 2x plus 1, 2x minus 1. This should be quick. We've done a lot of factoring this year, guys. So hopefully we're seeing those factors kind of rather quickly. We're reducing to 1 here, so we're left with. I'll just write it down here. I'll write it over here. How about up here? X over 2x minus 1. X over 2x minus 1. And if they ask you for restrictions, your k cannot be 0 for this one. K cannot be 0, and for this one, x cannot be 1/2. Cannot be 1/2 because 1/2 of 2 minus 1 that gives you, so it cannot be 1/2, and it cannot be negative 1/2 because that 2 times negative 1/2 would be negative 1 plus 1 is 0. Remember, you can't have 0 in the denominator. So this is just the restrictions from the other lesson that we were doing. Oh, went down too far. Okay, so uncommon denominators. For uncommon denominators, what I'm going to have you do, and as simple as this is, I think you guys can see that the common denominator would be 30 because 10 times 3 or 15 times 2, you're using the least common multiples. We're going to do this a little bit differently. What we're going to do is we are going to factor the denominator because when we get to more complicated ones, you're gonna appreciate the factors. So 10, and actually I'm going to do this right down here. 10 is actually 2 times 5. So we're actually going to factor the denominators. 15 is 3 times 5. Okay? So what you can see now is that we have a common 5, but we don't have a 2 over here, and we don't have a 3 over here. the groups of factors are going to be your common denominator. So we need, just think about what you're missing, basically. So what are we missing over here? We're missing a 2. So we're going to go multiply by 2 so that it matches this denominator over here. We need to get the denominators to match, and we have to do multiplying. So whenever you do to the bottom, you have to do the top. So we multiply the denominator by 2, we multiply the numerator by 2. Over here, we're missing a 3, so we're going to go times 3. That for the top needs to be multiplied by 3. So look at what we actually did here. We got 2 times 3 times 5, which is 30, and 3 times 5 times 2, which is 30. So we did get our common denominator of 30. We just did it by using the factors. Now you might say, Mr. Ventry, couldn't we just do times 3 over 3? Couldn't we just do times 2 over 2? Yes, you could for simple ones like this, but when we get into binomials and stuff and trinomials, it gets to be more complex. So you're going to appreciate the factors. All right, so 3 times 7 is 21, and then minus 4. So that gives us 21 minus 4, which is 17. 17 over 30. So 17 over 30 would be our final answer there. Here's another one. 12 is 2 times 3, and 21 is 3 times 7. 3 times 7. Using our prime factors. So here, I'm actually going to, well, yeah, we can do 2 times 2. That's fine. We're missing a 2 and a 2 here. 2 times 2. And here we're missing just a 7. So we're going to go times 7. All right, so we already had the 5. We already had the 4. Let's change colors here. What did we actually put in? We actually put a 7 here, so we have to go times 7 on top. Here, we put a times 2 and a times 2, so that's times 4 basically. All right, so now we're adding. So this is going to be 35. I'm just going to go up here. 35 over, well, let's see. 2 times 2 is 4, times 7 is 28, times 3 looks like 74. 84, and then 16 over 84. 21 times 4, 84. So 35 plus 16 is 51 over 84. So that would be our fraction. Now, again, could I have figured out it's 84 just by going 12, 24, 36, 48, 60, 72, 84, just by counting by 12s? And then 21 is 21, 42, 63, 84. So 84 is the common multiple. Yes, we could with numbers, but when we get down here, like I said, it would be a little more complex. All right, how do we do it with the variables? We'll throw those in now. Well, x squared is x times x. Okay, and this is 7 times x. That's already factored. So what am I missing here? I'm missing an x here. And here I'm missing a 7. So I'm going to go times 7. And then parentheses times 7. All right? So now I have 7 times x minus 3, which is 7x minus 12. No, minus 21. Over 7x squared. Plus 2x. I needed that additional x there. Over 7x squared. I have common denominators. I am ready to combine. 7x plus 2x is 9x. And then just minus 21 over 7x squared. And then, of course, we got to make sure that we reduce. So can I factor here? I could take out a 3, but if I take out a 3, nothing's going to reduce. So that's pretty much as simple as it can get. And of course, x cannot be 0. X cannot be 0. How about this one? Factor, factor, factor. All right, so I'm going to factor everything. We're going to go 2 over x plus 3, x minus 3, minus 5 over 3 times x plus 3, Now that it's factored, I can see the common denominator a little bit better. I have a 3 here, so I need a 3 over here. So I'm going to go times 3 over here. And now I'm missing an x minus 3 over here, so I'm going to do x minus 3 over here. So you see how breaking those basic factors down, example 1 and 2, or example 3 and 4, it helped us with this to see the common groups of factors. All right, so this is 6, and I'm going to go minus 5x, and then negative 5 times negative 3 is plus 15. That's where mistakes are made if we're not careful. 3x plus 3, x minus 3. Now I can simplify. I have 6 and 15 is 21 minus 5x over 3, and I'll call that x squared minus 9. We know that goes back to x squared minus 9, and that does it. We have nothing to reduce, and that's all we can do. We can't do 3 over 21. We have no common factor, so we can't go any further there. All right. Z over 1. Make sure you have fractions, both fractions. So you want to make sure anything that doesn't have a fraction, you put it over 1. And we need a common denominator. Well, z minus 1 is the only denominator we have. So therefore, we want to make this one z minus 1. So we're going to say, let's start this over. Z over 1 plus z over z minus 1. Z minus 1 is my common denominator, so z minus 1 has to go here. Therefore, you need a z minus 1 over here. So that's going to be z squared minus z, when you distribute that, over z minus 1 plus z over z minus 1. Do I have a common denominator? Yes, I do. So my common denominator is z minus 1. And up here I have z squared minus z and then plus z. So I have a negative z and I have a positive z. That's 0. So I just get z squared over z minus 1. That would be your final answer. And then we have 2 more examples. This is going to be x plus 4, x minus 4, and this one's going to be 4 minus x. Now, I'm going to write this over again. So I have 2 over x plus 4, x minus 4, minus 3 over just 4 minus x. Now, I don't like the way 4 minus x looks. I want it to be x minus 4. Remember, from 2 lessons ago, 4 minus x is the same thing as x minus 4. There's just a negative 1. So what you can do is say this is negative 1 times x minus 4. 4 minus x is really just negative 1 times x minus 4. So that's how we're going to do it. We're going to change that. We're going to get rid of that, and we're going to say it's negative 1 times x minus 4. Well, look what happens here. I have a negative 1. Whether the negative's on top or on the bottom, it doesn't matter. So that negative 1 can just be brought to the top of the fraction, making it negative negative 3. What's a negative negative? A negative negative is a positive. So what we're going to do is we're going to change this to a plus, and we're going to make this x minus 4. which helps us get to our common denominator. We're almost there. We have x minus 4, x minus 4. Now all we need to do is make it x plus 4, and then I'll need an x plus 4 on top. So that's a little trick you can use when you have 4 minus x or whatever, it's the wrong way. Make it x minus 4 and just change the sign to a plus. If it was a plus, you would make it a subtraction. All right, so we have x minus 4, x plus 4 is our common denominator. And then here I have 2, and then I have plus 3x, and I have plus 12. So that's 3x plus 14 over x squared minus 16. I multiplied it back out. You don't have to. You could leave it as x minus 4, x plus 4. All right, last one. Factor. X plus 5, x minus 5. This one's going to be x plus 5, x minus 2. And, okay, so we're missing an x minus 2 over here. So we need an x minus 2 over here, up here. We're missing x minus 5 on this side. So we're going to go x minus 5 here. What's that leave us with? Distribute. Leaves us with 4x minus 8 plus distribute 2x minus 10 over x plus 5, x minus 5, x minus 2. So that's 6x minus 18 over x plus 5, x minus 5, x minus 2. And we could take out a 6, but if we take out a 6, it's just going to be x minus 3, and there's no x minus 3 to reduce with, so we're just going to leave it 6x minus 18 over x plus 5, x minus 5, x minus 2. I think I kind of got away from the restrictions, but, you know, x, so for this one, restrictions, x cannot be 5, x cannot be negative 5, and x cannot be 2. Okay, whatever's going to make the denominator 0. Here we had x cannot equal 4, negative 4. 4, negative 4. All right. So I think that's good. We'll practice in class tomorrow. Then we'll go on tomorrow to the next day to lesson 19. See you then.